Okay, so for this example, we will let f of x is equal to 2x squared plus 3x minus 1. We will use the definition of the derivative in which we use the slope of a tangent line to get the derivative of a function. And we also show you the alternative definition of the derivative. Okay, it means that we will use the second one. We will find the f prime of negative 1. Okay, so for the first method, definition of the derivative, so in the slope of a tangent line. So the given here, the x sub 0 is at x is negative 1. We don't have the f of x sub 0 yet, and it's very useful for our um, formula for the definition of the derivative, which is f prime of x is equal to the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0. And again, the f of x is given, while the f of x sub 0 is unknown, but the x sub 0 is given, which is at negative 1. Let's get the f of x sub 0. So the f of x sub 0 is equal to 2x squared plus 3x minus 1, or that's f of negative 1, which is 2 times negative 1 squared, or 2 plus 3 times negative 1 is negative 3 minus 1. So 2 minus 3 minus 1 is equal to negative 2. That's our f of negative 1, or the f of x sub 0. Okay, let's solve the derivative. Okay, f prime of negative 1 is equal to the limit of 2x squared, our function, plus 3x minus 1 minus the f of x sub 0, which is negative 2, all over x minus the x sub 0, or negative 1, as x approaches the x sub 0, or negative 1. Next is to solve it. So 2x squared plus 3x and negative 1 plus 2 is plus 1 over x, negative times negative is positive, so x plus 1. This is indeterminate form. If we direct substitute the value of x when negative 1. So to get the value, let's just manipulate it by factoring. So the factor of 2x squared plus 3x plus 1 is 2x plus 1 times x plus 1. You can see that x plus 1 is common in the numerator and the denominator. We could cancel this one. Oh, okay, the remaining is 2x plus 1. So the limit of 2x plus 1 as x approaches negative 1, just direct substitute the value of the value of x with negative 1. So negative 1 times 2 is negative 2 plus 1. This is negative 1. So this is the derivative of the function at x is equal to negative 1 using the definition of the derivative, or the first method. Okay, the second method is by using the alternative definition of the derivative. Okay, so the alternative definition of the derivative is f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Okay, so it is all the c here in the second definition, it's always equal to 0. Now let's solve the f of x plus h. Our f of x is 2x squared plus 3x minus 1. We will expand all the values of x and it becomes x plus h. So 2 times the x here becomes x plus h squared plus 3 times the x again, which is x plus h now, minus 1 minus the function, which is 2x squared plus 3x minus 1 over h. Now let's expand it. X plus h squared is x squared plus 2xh plus h squared multiplied by 2. Then it becomes 2x squared plus 4xh plus 2h squared. Plus 3 times x is 3x plus 3 times h is 3h minus 1. And then we will multiply all terms by negative. So change sign, negative 2x squared minus 3x, and negative times negative is positive. So plus 1. Combine like terms, 2x squared minus 2x squared is 0. 4xh, um, there's no partner. 2h squared, no partner. 3x minus 3x is 0. 3h, okay, no partner. And negative 1 plus 1, this is 0. So Okay, so 2h squared plus 4xh plus 3h over h. This is indeterminate form 0 over 0 if we direct substitute the value of h with 0. So let's factor this one first. So h times 2h plus 4x plus 3, that's the factor. We can cancel h now. So what remains is 2h plus 4x plus 3. If we substitute the value of h with 0, so 2 times 0 is 0. So 4x plus 3. This is the general expression of our derivative um, with a given function 2x squared plus 3x minus 1. Now we get the value of f prime of negative 1. So using the expression 4x plus 3, so the f prime of negative 1 is 4 times negative 1 plus 3. That's negative 4 plus 3 or negative 1. So you can see that the answer is also negative 1 here using the alternative definition of the derivative. Okay, it may look like a little bit longer in this process, but trust me, um, it has its own advantage. Okay, so let's have another example here. Okay, let f of x is equal to 2x cubed plus 4x, and we will find the f prime of x, f prime of 2, and f prime of negative 3. Okay, so we will use the second or the alternative definition of the derivative. Okay, so the f of x plus h, so 2x cubed, let's expand x, so 2 times x plus h quantity cubed plus 4 times the x here is x plus h minus the function 2x cubed plus 4x. Let's expand x plus h cubed, so x squared plus 3x 8 x squared h plus 3x h squared plus h cubed, then 2 plus 4x, 4 times x, and 4 times h is 4h minus the 2x cubed plus 4x. Next is let's distribute 2 here on the parentheses. So that's 2x cubed plus 6x squared plus h plus 6x h squared plus 2h cubed plus 4x plus 4h, and then distribute negative sign here. So negative 2x cubed minus 4x. Combine like terms, 2x cubed minus 2x cubed is 0, 6x squared h is here, 6x h squared, no partner, plus 2h cubed, no partner, 4x minus 4x is 0, and then plus 4h over h. You can see this is indeterminate form 0 over 0, so let's um, factor this one. So the factor is h times 6x squared plus 6xh plus 2h cubed plus 4 over h. So we can cancel h. So what remains is 6x squared plus 6xh plus 2h squared plus 4. And we will substitute the value of h with 0. So it becomes times 0 here. So 6x times 0 is 0, 2h or 2 times 0 squared is 0 as well. So what remains is 6x squared plus 4. So this is the general expression of our derivative 2x cubed plus 4x. The general expression is 6x squared plus 4. And it's very useful to get the derivative of the f prime of x, of f prime of 2, and f prime of negative 3. So the derivative f prime of x is 6x squared plus 4 itself. The f prime of 2, we will be using the general expression 6x squared plus 4 and plug in the value of x, which is 2, so 6x squared, so that's 24 plus 4 is equal to 28. And lastly, the f prime of negative 3. The f prime of negative 3 is 6x squared, so 6 times negative 3 squared, 9 times 6 is 54, plus 4 is equal to 58. So that's the major difference between the first definition and the second definition. The second definition, we could use that to all values of x as we get the general expression of the derivative. Unlike with the first definition of the derivative, in which we have to solve every value of x on the same process. So So that's all. Thank you for listening. I hope you've learned something about the derivative of function. God bless and goodbye.